How to fix a broken wire without soldering. There are 4 professional ways to connect wires. We will use Wago splicing connectors, crimp wire connectors, heat shrink tubing, and insulation tape. Not all methods are of the same quality, so they are ranked from better to worse. Take the insulation stripping pliers and gently remove the rubber insulation from the wire. Be careful not to damage the cable. Do not use a knife, scalpel, or other blades, because you will easily damage the wire if you are not trained. A damaged wire can disrupt current transmission and damage the connected device. Wago wire connectors are the standard in the world for joining wire without soldering. They are used in connecting electrical installations and walls. They are made of very high quality material and can withstand very high currents. Wago company tested them against fire and other harmful conditions. All you need to do is plug one end of the cable into one port and the other end of the cable into a different port. The WAG connector will close and will not allow the cable to come out. They are small in size and can be used for all types of cables except for skinny wires. The link to these tools is in the description. Crimp connectors are similar to Wago connectors. Crimp connectors are also a good choice and are most often used for tiny thickness cables, for which Wago connectors cannot be caught. When inserting the cables into the crimp connectors, it is necessary to use special pliers that will press the line at an angle to no longer be detached. As I said, this method is best for small thickness cables because it connects them very effectively. Step 1. Remove the insulation from the wire using pliers to remove insulation. Be careful not to damage the wire. After that, go to the other end and remove that insulation as well. Step 2. Insert both ends of the wire into the crimp connector. Try to push the wire as far as possible. The more wire goes into the connector, the better the connection will be. If you cannot insert the wire, try twisting it beforehand. Step 3. Take the pliers with which you previously removed the insulation. Place the crimp connectors in the middle of the pliers as shown, so the sizes match. Press hard and wait a few seconds. Then release the pliers. This method is a bit more complex and not as good as the previous 2, but it can serve you quickly. This is not recommended for long-term use because the heat shrinking tube can come off after a while. Step 1. Remove the insulation from the wire with pliers and place the wire in this position. Step 2. Add a shrinking tube to one end of the wire as shown in the picture. And then twist wires from start to finish to look like I did. Step 3. Now bend the wire into the position, as in the picture, from left to right. The wire should run parallel to the other end. Step 4. Place the shrinking tube over the wire so that it covers everything. It must not protrude at either end of the wire. Step 5. Using a lighter, heat the shrinking tube until it collects. In the end, you should get this look. This method is similar to the heat shrinking tube. Only we will use insulating tape here. Do not do this if you have the option of one of the other methods. When you twist the wire, wrap it with insulating tape several times. Today, it isn't easy to find quality tape because the glue dries and separates very quickly in almost all of them. First, remove the insulation from the wire, then twist it. Now twist the wire with insulating tape. The more times you twist the better. The well-connected cable carries electricity well. A poorly connected cable has power badly. Very simple. Poor power transmission can damage the device connected to this cable. All machines from the microwave to the car parts run on constant current. This means that they need the same current all the time to function. This will extend the life of the device. Also, suppose the connected wires are disconnected. In that case, this will lead to a rapid power failure that can damage components in some electronic devices. To check the correctness of the cables, you need to use a continuity testing device. Usually, the first thing people think of is a multimeter. There are tools designed to test wires like a wire tracer. They are not expensive and they do an excellent job. They connect 2 cables and send an electrical signal. If the cable is well connected, an audible signal will sound and the lamp will light up. This device can indicate without contact whether current is present and passes through the wire. It is practical, and my honest recommendation is to get yourself one such device. The link to this device is in the description.